Alright guys, so tonight for homework we're going to help out Dean Vasta. Dean Vasta was wandering the hallways and he discovered a white powder and some unknown substance. He doesn't know what it is. So he brought it to us to help figure out what he's dealing with. So instead of bringing in the dogs from the police and sending a student to jail, we want to make sure that we'll take care of things first here. So without further ado, we are going to tackle the case of the unknown substance. However, before we can do that, we have to analyze the substance to get some information. And basically, once we analyze the substance, what we do with the results is what you're going to have to learn how to do tomorrow in class. And it all revolves around this idea of empirical formulas. Now, we've already talked about empirical formulas previously, and empirical formulas are the lowest whole number ratio of elements in a compound. And it's not necessarily the exact number of elements in a compound, all right, but it's the lowest whole number ratio of a compound. So if we looked at sugar, all right, sugar is C6H12O6. That's its exact formula. That means it's got 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. But if we looked at the lowest whole number ratio of sugar, the empirical formula would be CH2O. All right, everything's divisible by 6. Now, we're going to take some steps to finding the empirical formula. The first step is that you need to calculate the moles of each element. So if you're given mass, you simply just convert those grams to moles. If you're given percents, you need to assume 100 grams because percent is based off 100. Then you're going to solve for the number of moles. You then would divide by the smallest number of moles, and this should, but not always, give you whole number ratios. We'll talk about what to do if this does not give you whole number ratios. We're going to come back to this. And then, basically, that's your empirical formula. So, back to Dean Vasta. I would pause it here, take these down in your notes as your steps, and then hit play. So, to the lab. So, the lab tells us that this chemical has 32.5% sodium, 22.5% sulfur, and 45.1% oxygen. So going back, we know that step 1 is to assume 100 grams. So each of these grams, or each of these percentages, is just going to be converted to grams. So we're going to have 32.5 grams of sodium, 22.5 grams of sulfur, and 45.1 grams of oxygen. So step 2. Now that we know our grams, we're going to convert the grams to moles for each element. So all we're going to do is set up our unit conversions for each element. We're going from grams, so grams is going to be on the bottom for each. And we're going to go to moles, so moles will be up top. We know that the number that goes next to mole all the time is 1. And when we go from grams to moles, the number of grams in 1 mole is going to be the mass from the periodic table. For sodium, that's going to be 23. For sulfur, that's going to be 32. And for oxygen, that's going to be 16. If we do our mole conversion, 32.5 grams of sodium divided by 23 grams of the molar mass of sodium That gives us a value of 1.41. All right, if we did the same for sulfur, that gives us a value of 0.703. And for oxygen, it gives us a value of 2.81. Step 3. Step 3 asks us to divide by the smallest number of moles. Well, in this case, the smallest number of moles is 0.703 moles of sulfur. So we're going to divide each of these moles by 0.703. And we calculate a value for each. In this case, it's the whole number that is given to us. We now take these whole numbers, 2, 1, and 4, and that's going to give us our empirical formula. So we now can write the empirical formula from our mole ratios. For sodium, we had 2. For sulfur, we had 1, and the 1 is assumed. And for oxygen, we had 4. So our empirical formula is Na2SO4. So the substance that was unknown that Dean Vasta found was just sodium sulfate. Now, what to do if our ratio of moles does not equal a whole number? If the numbers are not whole numbers, what you're going to do is, if it's 0.5, you'll multiply all the numbers by 2. If it's 0.3, you'd multiply all the numbers by 3. 0.25, multiply all the numbers by 4. Or if it's 0.2, you'd multiply all the numbers by 5. You probably will not see any of these in your problems. You may, however, see a problem that has something like that. All right, and what you need to do is make sure you multiply all the numbers by 2, not just the number of the atom that's at that 0.5. That's it for tonight. Tomorrow night we'll take it one step further and go from empirical formulas to molecular formulas.